Okay, and the last thing we're going to talk about today is how to solve systems that come up in SAT problems. So for number 5, consider the system of equations, and we're given this example right here. You have to decide how many solutions they have. So I'm going to start out with this top equation and just distributing this 44 in and see what I get. That's going to give me 44j plus 88k equals 12. Now, I kind of want to consider when I'm working on this one, I know I'm going to add the 11j over, and so I would have 11j plus 22k equals 16. And as I kind of try to compare that to what I have here and what I'm going to eventually want to potentially cancel, because I would use elimination for this one, I want my either the 44j to cancel or the 88k to cancel. Either way, I need to multiply this by a -4 to make that happen. So what that's going to do is it gives me negative 88k equals 44j minus 64. Now from here, if I subtract that 44j over, I now have negative 44j minus 88k equals negative 64, which I can bring over to this equation. Last thing here is that we're going to go ahead and cancel our j's and k's, which gives us 0, so we know it's a special case, is equal to negative 52. Now, one thing I want to mention down here is that there is no way we're going to get exactly 2 solutions. A system can only have no solution, one solution, or infinitely many solutions. Now, this results in a special case. So right now, we should be thinking it's either 0 for no solution or infinitely many. Now, when we get a statement that's not true, we want to remember that that means that there's no solution. So this answer should have been A. Okay, in example 6, this is an example of something that could be on an open-ended portion of the SAT. Here, we want to figure out if the system has no solution, what would the value of C be? So again, we want to kind of think about the fact that if it's no solution, we need our y's to cancel and we need our x's to cancel. Now, if I wanted this set of y's to cancel, all I'd have to do is multiply the bottom equation by a -1. That would make these cancel. Now here what I would have to have is this value for C would definitely have to either be positive or negative 1/2. But if we think about it, if these already match, we want these to already match too. So if I make the C value 1/2, that's what's going to make this no solution. Because then if I were to multiply the whole bottom equation by a -1, now my y's would cancel because it'd be a y and a negative y. My x's would cancel because it would be 1/2 x and negative 1/2 x. And then it really, as long as these are going to give us different numbers here, it would be no solution. And our last example here, in the system of equations below, what is the value for x over 2? And we want to be careful of this. They are not looking for us to solve for x. They want to know x over 2. So if I'm trying to solve this for x here, what we would want to start out with is figuring out a way to get rid of our y values. So what I did here is I multiplied I'm multiplying the whole bottom equation by a 4. That's going to make this y value down here become a -2y, which will ultimately make the y's cancel. Now, you could have done this a different way, but the best method is to go ahead and cancel out your y's and solve for your x's. So this is then going to give me, I'll leave the top equation alone, but the bottom one, 4 times x is 4x. As we talked about, 4 times negative y over 2, 4 and 2 cancel, I get -2y, and then 4 times 1 is 4. Now from here, our y values cancel, and what we're left with is if I've got x over 2 plus 4x, I need to think of this 4 as being like 8 over 2, so that when I combine them, I've got 1 over 2 plus 8 over 2, which is 9 over 2. The x can stay in the numerator, or we could write it next to. From there, we're going to multiply both sides by 2. You actually could multiply both sides by 2 over 9 if you wanted, but I thought this might be a little easier for us to visualize. These 2's then cancel, so we get 9x is equal to 18 times 2, which is 36. We divide both sides by 9, and then we get x is equal to 4. Now remember, that's not the answer. So from here, we're looking for the value of x over 2. So what we'll do is take that 4, plug it in for x. We get 4 over 2. That reduces down to 2. So we think that D is the answer. Now, if you have time on the SAT, Even if you want to just come back to this at the end of the SAT if you still had time left. We want to plug that value in. So we got 4 for x. So if I plug in 4 over 2, or we could just say that x over 2 was 2. Either way, we've got 2 plus 2y is equal to 14. We solve it. We get y is equal to 6. Now, how do we know if this is true? Well, if my x value is 4 and my y value is 6, if I plug that back into both of these equations and it makes them true, then I know I have the correct answer. So 4 over 2 is 2. 2 times 6 is 12. 2 plus 12 is 14, so that one's good. Down here, I've got 4 minus 6 divided by 2. 6 divided by 2 is 3, so 4 minus 3 is 1. So now I know that we have the correct answer. So for tonight's homework, you have 4 sections that you're going to complete in Delta Math. This is the last assignment before we move into using our practice set for Unit 1. If you have any questions, please let me know.